Welcome to another Microsoft Access tutorial. Today we're going to talk about variables, dimensioning them and beginning to use them so we can understand how in our VBA code we can use variables to embellish our programs and move data around and actually perform calculations and analytics on data eventually as you use them. So first, let's go over a few rules. The first rule is it must begin with an alphabetic character. So when you name a variable, it has to start with a non-numeric, non-punctuation character, A through Z. It can be capital, it can be lowercase, but it has to be a character A through Z. Second, it has to have a unique name. The unique name is throughout the module that it's used in or throughout the procedure that it's used in. In other words, you can't use it and then determine that you want to use it again unless you really mean to use that particular variable. The third rule, which looks very similar to the second rule, is that the variable cannot be used elsewhere in the procedure or in modules that use the variables. What that's meaning is the first one's, disannulled the fact that you can't use the same variable for two different purposes within the same modular procedure. What this one says is you can't go naming another procedure or a function or another module. You can't go ahead and name it the same as a previous variable, okay? The fourth rule is that you can't use spaces or punctuation within your variable name. You can use an underscore, but that's about the only character. Underscores and dashes you can use, but you can't use regular punctuation characters like commas or periods or pound signs or things like that within your variable names. The fifth rule is you cannot use the same as a reserved word in Access. Those names would be such as the word now, because now is used to promote the current date and time in the system. Access gets confused if you try to name a variable by that, but the name of the variable is the same as a function. The last one is rule number 6. It can't be any longer than 255 characters. Now, truthfully, I hope none of you try to create a variable that's even close to 255 characters in length. That would be onerous and difficult to use on it, just on its face anyway. So those are the 6 basic rules. Now, there's 4 suggestions that I would like to give you concerning how to name your variables. First off, you should choose some convention for naming your variables. The first type of convention is sometimes referred to as camel casing, like in the word total cost. Total cost has the capital C. There's no space in between them, no underscore between them, but so you see a capital letter in the middle. So a lot of times that's using upper and lowercase letters. Sometimes you'll hear the term camel casing for that in some places that do programming. You can use just all lower cases instead. So you don't capitalize the first letter. You just, everything is lowercase from the first letter all the way to the end. The third suggestion would be to choose a naming convention that puts underscores instead of spaces and make your variables look like actual names, like total cost with a space in between replaced by the underscore as you see on the screen there. The last one that I would suggest here, number 4, is preceding the name of each variable with a lowercase letter representing the type of data that's in that field, like if it's numeric, an I for integer, or a D for double, or an L for long. So you've got all of those types of conventions that you can use, but what you really need to do is choose the convention you're going to use at the very beginning and stick with it the whole time, because it'll make your code much easier to read. So what I'm going to do now is I'm going to go ahead and pull up a Microsoft Access container here, and I want to talk about how to initialize your variables. Now, there's 2 ways to initialize a variable. The first way is implicit. You basically don't initialize it. You don't tell what data type it's going to be. And by not telling what data type it's going to be, it has to imply, based on what you put in that variable, what the data type is going to be. So I'm going to open module here, And if I were to implicitly define some variables, I'm going to just pull some code over here so you don't have to watch me type, and I'm just going to paste it in here. And here we've got an example of 3 variables that we're defining, and they're going to be totally implicit. In other words, I just started with first name and I'm stuffing Richard in there. I'm going to take last name and I'm stuffing my last name in it. And then my S full name, I'm going to go ahead and concatenate the 2 with a space in between here. And then I'm going to output it with a message box just to prove that we did it correctly. Now, this will work, but there's a few downsides. So let me go ahead and show you that it outputs the message box here and says Richard Hansen. It put the space in between. Did exactly what we would have expected it to do. But implicitly defining your variables means that you won't have the lines at the beginning telling what kind of data type it is. And what happens is the program comes up to that particular variable and it then says, well, I don't know what's going to go in here, so I'm going to give it a variant data type. Now, a variant data type is basically a catch-all for everything. In other words, you can put text in there, you can put a number in there, you can put a blob in there, you can put a picture in there. It's going to reserve enough memory to do any type of variable that it wants. And by doing so, what you do is you can bloat your program if there's a lot of variables. And so you should get in the habit of explicitly defining your variables. Now, to explicitly define your variables, I'm going to go ahead and pull over another bit of code here and show you what explicitly defined variables look like. Now, here we have these 3 lines at the beginning that we didn't have before. We're going to use the keyword dim for dimension. We're going to do first name as a string, then last name as a string, and then we're going to define full name as a string. Now, that's what you would have expected. And the naming convention here is a mixture of camel casing. First and F and N are capitalized in first name, and S denotes that it's a string. Okay, so you can see a little bit of the naming convention working here. And then I'm going to still output, all this code is the same as what we had above. And then when we actually run this code, you'll see it works the same. But what it's done, though, is if I were to do a test here and put some variables together and define a lot of different variables and define them as implicit versus explicit, you'd see there's going to be a difference in speed, and you'll see a difference in the amount of size if you get enough of them. So it's always just a good practice to explicitly define your variables, okay? So I would then want to explain this dim keyword here. When I use dim, I'm going to dimension it, and it's going to die after my subroutine is done. So that those variables last for as long as it takes to output this and hit this end sub. Once it hits end sub, Microsoft Access is going to deconstruct those variables and return the memory back to the program. By doing so, you would then have to redefine those variables if you used them elsewhere. So in other words, the domain of those variables is only in this subroutine here. Now, if I were to decide I wanted to do a public variable, and let's say first name, I could do so and put it up in the header. And if I did, this set of programs right here is in this module. And by doing so, and I got to put as string here, okay? By doing so, I've just defined those to be good for this entire module, okay? Now, by doing so, I can use this defined here, and it will be explicitly defined for both of these, and I would not have to have this statement here like this, and it would still be explicitly defined, okay? So the domain of public allows it to be used throughout the entire module. The domain of just this dimension command is only used in the subroutine or this procedure. And there's also one other called private. Now, private it can be used in this level. If I define a private variable, in other words, I say here, and instead of saying dimension, I say private, okay? So that private string will only still be just as good as the dimensioned string that I used. So private and dimension in this context is the same. But if I went up here and decided to go private and define s last name as string, if I defined it up there, that private variable would be good for the entire module. In other words, it's a flexible command, public versus private. My preference is to use dimension when I know I want it to be just for that subroutine, and I use public if I truly want it to be a global variable. Private is kind of an in-betweener that Access has there. I don't find much valuable to it, but you'll see it occasionally in those kind of programs. Now, there are a lot of different data types, and you'll see data types and need to know about the data types. The basic ones are the math ones. You'll see currency, you'll see decimal, you'll see date, which is a numeric data type, double, integer, long, object, and single, okay? Then in the text variable types, you'll see string, you'll see variant, okay, it can have numbers or text in it, and you'll be able to use these, all the way through your program. Now, there are some data types that exist on Microsoft Forms or in the tables that don't exist in VBA. Like, for example, you can't use in VBA an auto number, but auto number is definitely a type of long integer. You would use the long integer type of data in your VBA code, whereas the auto number would exist in the table. Now, you couldn't auto increment it unless you manually did it with a for next loop or an if then statement and looped through to create those and put them in the tables, that type of thing. So there are some that aren't. Another one is that you don't have a variable type called OLE object, where you have an OLE object that you can put in a table, for example. So data types are important. Dimensioning your variables as certain types of data are important. Explicit versus implicit. Oh, one last thing I want to show you. If you come up here and you say option explicit, option explicit will force you to change those to explicit declarations for the variables. And by doing so, by putting option explicit at the beginning of your module, you can make sure that you remember to define all your variables in an explicit manner rather than being implicit. And a lot of times that'll improve your code quite considerably. So I hope you've enjoyed the content here. Hope to see you again soon. Thanks. I want to thank you so much for viewing this video. We have great content on the site, and I'm putting more content out every single day. There's a link to one of them on the side of the screen over here. Also, please help me grow the channel by subscribing. So hit that subscribe button a little bit lower on the other side of the screen, and hope to see you again. Thanks.